I would be excited about geometry, but I guess not everybody in the world fits my opinion on that matter. But anyway, welcome everybody. It is time for class number 8 for geometry. Okay, well this is fairly similar to algebra in a lot of ways. In fact, later on in the course, we're actually going to be covering some of the same stuff that we covered in algebra, just because it's relevant to both algebra and geometry. Okay, oh wow, okay, so I guess it's Thanksgiving week, everybody taking it easy a little bit, and we'll have to, I guess, adjust accordingly. But anyway, it is class number 8, and this class number 8 is about quadrilaterals with parallel lines. I'm kind of going to zip through the slide because really everything that's on the slide we've already covered in the past. But what I would do is just spend a few minutes going over the slides, and once we finish the slides, then we will actually go through a bunch of these practice questions over here that I have lined up. And by the end of the day, hopefully we will all be certified experts in doing geometry problems that are relevant to quadrilaterals. One of the foremost types of types of quadrilaterals is, of course, the parallelogram. Now, the parallelogram simply means a figure with two sides that are parallel to each other. Both sets of sides that are parallel to each other. This is parallel to this, and this is parallel to this. Now, of course, by definition, that's not the only thing that a parallelogram has going for it, but that is what defines a parallelogram. That is why it is called a parallelogram. Now, a parallelogram also has certain other rules that all parallelograms follow. Now, as we discussed earlier in the course, the good thing is that you only have to show any one of these things, and then you can show that the figure is a parallelogram. For example, opposite sides are equal. If I show that both pairs of opposite sides are equal, it is a parallelogram. If I show that both pairs of opposite sides are parallel, then it is a parallelogram. Pairs of opposite angles, this to that, and this to that. Pairs of consecutive angles are supplementary, so if I have a 1, 2, so if I say angle 1 plus angle 2, that has to equal 180, and 3 and 4, angle 3 plus angle 4 equals 180. Although, does everybody see why if I have the first one, then I automatically have the second one? If I have 1 plus 2 equals 180, then by definition 3 plus 4 has to equal 180. And the reason for that is a quadrilateral has 360 degrees. All four angles of a quadrilateral have 360. So if 1 plus 2 have to equal 180, well then by definition 3 plus 4 have to equal 180. Okay. So pairs, diagonals bisect each other. So if I have one diagonal here and one diagonal here, that means this side is equal to this, and this is equal to this. And it also means two congruent triangles, which means that this entire triangle, well, let's assume that I filled in this whole thing. This whole triangle is congruent to this whole triangle. The blue triangle and green triangle are congruent to each other. Those are some of the, well, those are really the earmarks of a parallelogram. If you prove any one of these things with regard to a quadrilateral, then the quadrilateral by definition has to be a parallelogram. Now we're going to look at 3 subtypes of parallelograms, all of which we've already covered in this course, but I'll go over them quickly again. Next, you have a rhombus. A rhombus is a 4-sided figure where all 4 sides are equal to each other. Well, a square, as we'll see a little bit later on, is a type of rhombus. But if you have a parallelogram, or really any quadrilateral, with 4 sides that are equal to each other, then by definition the shape has to be a rhombus. All 4 sides are equal, and that's really what differentiates it from an ordinary parallelogram. Although, of course, it is a type of parallelogram. A couple of other rules regarding a parallelogram over and above, a rhombus over and above a regular parallelogram. First of all, diagonals are not only bisecting each other, they are also perpendicular, which means this forms a right angle, which means all four of those angles in the middle equal to 90 degrees. And second of all, diagonals bisect the vertex angle. So this angle, let's say angle 1, is equal to angle 2. Angle 8 is equal to angle 4. Angle 5 is equal to angle 6, and angle 7 is equal to angle 8. In a rhombus, the diagonals bisect each angle. And again, proving any one of these is true proves that the quadrilateral is a rhombus, even if you haven't proven any of the parallelogram rules. So if I somehow prove that I've got a quadrilateral and the diagonals are perpendicular, that has to be a rhombus, which of course also means it has to be a parallelogram, because a parallelogram is a type of rhombus. Then we've got the rectangle. The rectangle is a parallelogram that has a right angle. Let me try to draw a little bit of a better, but maybe draw a little bit better than that. Okay. All right, not a great rectangle, but close enough. Okay. A rectangle is a parallelogram with a right angle, and because it has a right angle, that also by definition means it has four right angles, because opposite angles are equal. So if this one is 90, then it has to be 90, and because the consecutive ones are supplementary, this one also has to be 90, and therefore this one also has to be 90. A rectangle has all the rules of a parallelogram, plus diagonals are congruent, which means this line and this line, let's say AB and CD, are congruent to each other. They're equal to each other. And of course, it also has a right angle. What if you combine the features of the rectangle and the rhombus, and you have essentially a rhombus with a right angle? Well, then you get a square. A square is a four-sided figure, a quadrilateral, where all four sides are equal and all four angles are right angles. This is a right angle here, and this is equal to this, which is equal to this, which is equal to this. It's a rectangle with four equal sides, or you can call it a rhombus with a right angle. Either way, that is a square. So, this of course has all the rules of a rhombus, all the rules of a parallelogram, all the rules of a rectangle, plus the diagonals are equal and perpendicular. Now, if you think about it, that's really pretty self-evident, because they're perpendicular because it's a rhombus, and they're equal because it's a rectangle. And also, all these four triangles, this triangle, this triangle, this triangle, this triangle, are all congruent to each other. Alright, everything's a right angle, everything's equal, everything's happy. The square is, the perfect two-dimensional shape. Okay, now we've got the type of quadrilateral where only one pair of angles are congruent to are parallel to each other. Sorry, I don't know why that closed, but I'll open it again. Okay, that means this side is parallel to that side. Just having one pair of parallel sides and not the other pair of parallel sides makes it a trapezoid. What are the rules of a trapezoid? Well, the only other rule besides the fact that opposite sides are parallel, and besides, as we learned before, if you want the area of a trapezoid, you have to do the average base times the height. you know, base 1 plus base 2 divided by 2, which is the average base, times the height. That would be the area of a trapezoid. But in a trapezoid, consecutive angles are supplementary. So if this is angle 1, this is angle 2, this is angle 3, and this is angle 4. So angle 1 plus angle 2 equals 180, and angle 3 plus angle 4 equals 180. That is a trapezoid. And then we've got a special type of trapezoid, which is the last slide here, is an isosceles trapezoid. Two sides are equal, but the others are not. On the bottom over here, we've got a trapezoid because one set of sides are parallel, and the other set of sides are not parallel. And it's an isosceles trapezoid because the two sides are equal to each other. Okay, what are some of the special rules over here? Well, the non-parallel sides are equal. That obviously is what makes an isosceles trapezoid. The diagonals are equal. So if I draw a diagonal to here and a diagonal to here, these two diagonals, say AD and BC, are congruent to each other. And the angles are also equal. Opposite angles or base angles are equal. So this angle C is equal to angle D, and angle A is equal to angle B. Very similar to an isosceles triangle, where the base angles are equal as well. Okay, so with all of those rules in mind, let us now go to some problems. And I've got a whole bunch over here. Let's do this one first. This is a good one here. 1 second. Again, I'm going to have to copy and paste these as we did last time. One second. Okay. Okay, there we go. And now I have to get the given rules over here. Give me 1 second. And here's the problem. There we go. All right, here we go. Let me grab the pen over here. Given measure angle A is 3x plus 9. Measure angle B is 5x plus 20. Measure angle C is 3x. And measure angle D is 2x plus 6. Find measure angle D. Okay. What do we know about this quadrilateral that will help us with this? Well, is it a special quadrilateral? Is it a trapezoid? Is it a parallelogram? Is it a rhombus, square, rectangle? It's really none of those things. It's just a regular, plain old run-of-the-mill parallelogram. We don't know anything about quadrilateral. We don't know anything special about this quadrilateral. But what do we know about it by virtue of the fact that it is a quadrilateral? And the answer is that, of course, the angles have to equal up to 360, because every quadrilateral's angles have to equal up to 360. So let's add them all up and set the whole thing equal to 360. So A, which is 3x plus 9, plus B, which is 5x plus 20, plus C, which is 3x, plus D, which is 2x plus 6, has to equal up to 360. And once we have this, now we could solve it like a regular equation. Let's combine all the x's. 3x, 5x, 3x, 2x. That's 8 plus 5, which is 13x. The numbers, well, we got a 9, we got a 20, and we have a 6. So that at least seems to be 35. Equals 360. So let's subtract 35 from each side in order to isolate the x term. So now we've got 13x equals 325 divide by 13, and, well, without a calculator, I'm going to do this without a calculator. Okay, 260 is 20, so that's 25, no? Isn't that 25? Okay, anyway, yeah, 25. Okay, very good. So x is 25. What was the question? The question was, what was measure angle D? Well, that's 2x plus 6. 2 times 25 is 50, plus 6 is 56. And then, for fun, we can do the rest of them. 3x plus 9 is 75 plus 9, which is 84. 5x plus 20 is 125 plus 20, which is 145. And 3x is 75. Now, do these all add up to 360? Well, they better. 56 plus 84 is 140. 140 plus 145 is 285. 285 plus 75 is 360. Very good. So we got it. All right. Let us take another one that is a little different, but also follows some of the rules that we've just discussed. Okay. Let's put that over here. And what are we given? And we're given this. Given square ABCD with a perimeter of 48 units, find the number of units in BD. Okay, how would we find this out? Well, first of all, if the perimeter is 48 units, so how long does each side have to be? Each side has to be 12, exactly. It's a square, and so the perimeter has to be 1/4 times the entire perimeter, which is 12. So how are we going to find B here? Well, how about this, of course, is a right triangle. Either side is a right triangle, so we can use the Pythagorean theorem. We can use ABD, or we could use BCD. Both of them are right triangles. And the formula for the hypotenuse of a right triangle, which BD is the hypotenuse of either right triangle, or both right triangles, is a squared plus b squared equals c squared, where of course c is the hypotenuse. So you'd have 12 squared plus 12 squared equals c squared. Either one would work out that way. So that's 144 times 144, which is 288, equals c squared. To isolate c, we'll take the square root of each side, and we have 2 equals the square root of 288. Now, can we break this down any further? Can we? This is really something from the algebra course that hopefully you may remember how to do. The answer is yes. We can divide this into a. We can take this into a perfect square and a non-perfect square. We can change 288 into the square root of 144 times the square root of 2. So, and we can change the square root of 144 into 12. So we can change this into 12 root 2. Or, you can just do on a calculator, what's the square root of 288, which I guess would be about 16.97. Or if you wanted to leave it in radical form, I think in this case, the instructions asked us to leave it in simplest radical form. So in that case, we would try to get it into a perfect square and a non-perfect square. So for example, if you have, let's say for argument's sake, you had square root of 75 or something like that, and you wanted to break that down, might be. So we'll still have an opportunity to do some of these, do a few more of these. If you wanted to, let's say, break down the square root of 75, you could think that hopefully you could remember that 25 is a perfect square. So you could break down that into 25 and 3, because 25 times 3 is 75, and then you could turn to 25 and 5 and call this 5 root 3. One thing that helps when you're doing these sorts of things is to remember the perfect squares. At least, for the perfect squares are, well, 1 squared is 1, 2 squared is 4, Then you got 9, 16, 25, 36, 49, 64, 81, 100. I'll go up to, let's say, 15, 121, 144, 169, 196, and 225. And hope maybe you can even remember a little higher. But when doing these kinds of problems, it helps to remember remember what the perfect squares are. Then really these are just 1 squared is 1, 2 squared is 4, 3 squared is 9, all the way up to 15 squared. That helps with these sorts of problems. If you see something like square root of 200. Well, right away in your mind, you say, well, 200 is divisible by 100, and 100 is a perfect square. You can change that into root 100 root 2, which is 10 root 2. If you have root 450, again, hopefully you could remember that 225 is a perfect square, and so that would give you that would give you 15 root 2. Okay. Let's take a look at another one over here. All right, this problem asks you to get side AD. They want you to figure out what side AD is. Okay, what do we know? Obviously, in order to get AD, what do we have to figure out? We have to figure out what x is. If we don't know what x is, we got no chance of figuring out what AD is. How do we figure out what x is in this case? Well, the only way to do it, because this is a parallelogram, actually it also gives you that it's a parallelogram, that's right. It also gives you that it's a parallelogram. And so because it's a parallelogram, we know that opposite sides are equal. So we know that 3x plus 5 equals 6x minus 10, because they are opposite sides of a parallelogram. Once you do that, well, now you can solve for x. Get all the x's to one side, all the numbers to the other. Let's say we subtract 6x from this side and 6x from that side. So we got negative 3x plus 5 equals negative 10. Now we can get rid of the numbers. Subtract 5 from each side to get negative 3x equals negative 15. And then we can divide by negative 3 to isolate the x. And then we get x equals 5. Once we have x equals 5, well, we can figure out these. 6 times 5 minus 10 is 20. 3 times 5 is 15 plus 5 is 20 also. It better be equal because they're opposite sides of a parallelogram. And on this side, on the left side, 4x is 20 minus 5 is 15. That's right. And of course, that also tells you BC is 15. I didn't ask you what BC is, but you could figure that out in the same way as well. All right. Let's try one more from this section, and then I'll do a couple of others. I also want to do one of the homework ones, which I thought was a very interesting problem. Okay. Okay. Well, there are people watching the recording, so we definitely want to clue them in, hopefully. All right. All right, there we go. I'm sorry. Okay, there we go. All right. Given parallelogram DEFG, and angles are as marked, find measure angle F. Okay. Well, what do we know that will help us find x? What do we know anything about the relationship between angle D and angle E? That's right, they're supplementary. So I can say 2x plus 12 plus 5x equals 180, because those two angles are supplementary. And now we can solve it like we would any other equation. 2x plus 5x is 7x, plus 12 equals 180. Subtract 12 from each side to get rid of the 12 and isolate the 7x term. And you've got 7x equals 168. And divide by 7, and that I believe you get 24. Yeah, 7 times 20 is 140, and then 7 times 4 is 28. So you got 24. So x is 24. That means 2x plus 12 is 2 times 24 plus 12, which is 60. 5 times 24 is 120. And of course, they have to be supplementary. So angle F is what? Well, angle F is opposite angle D. And opposite angles in a parallelogram are equal. So angle F has to be 60. Angle G, of course, as you hopefully know by now, is 120. And that's that. Okay. This is an interesting one. All right, let me let me put up this next one here. Okay, here is our figure. Given trapezoid ABCD, which triangle is equal in area to ABD? So first of all, these two sides, of course, are parallel to each other. And so ABD is what? ABD is this whole, I don't know why it's not filling in the whole thing, but so I'm just going to undo that, because it looks kind of ridiculous. But anyway, so ABD is this whole area, this triangle ABD. What triangle has to be equal to ABD? You know, let me mark it. Let me try to fill it in a different color. Let me try to fill it in red, let's say. All right, well, that's good enough, hopefully. Okay, how do we figure out what triangle? You know, this is not such an easy question. What other triangle is equal in area to ABD? Now, one thing we can do to try to figure out ABD is see if there are any triangles that are congruent to this whole thing. Now, we know that this angle is congruent to, no, I'm sorry, one second. No. We know that this angle is congruent to this because of alternate interiors. We know that it's a good question. How would we figure that out? You know, honestly, I'd have to think about this a little bit longer before I. Sorry for putting this one up, but let me do the next one. The next one should be hopefully a little. Honestly, I'd have to take a look at it in a little bit more detail. I don't want to sit here for 5 minutes while I sit there and figure out how to do this. But let's try this one. This one should be a little bit more straightforward. Okay, in this one, what they're asking us to do is to... they give us that this is an isosceles trapezoid, that this is congruent to this, and they also they want us to find side AQ. Sure, no problem. I'll get the link for you after class. All right, so let's take a look. Okay, so when we put over here, okay, so the question over here is, so how do we figure out AQ? Well, all right. Because these two are because AQ and EQ are first of all, because this is a trapezoid, this is parallel to this. Because AQ and EC are both perpendicular to the same parallel line, they have to be parallel as well. And because you have a parallelogram here with right angles, what is this shape in the middle? The shape in the middle is a rectangle, right? By definition, it has to be a rectangle. We know it's a parallelogram because the opposite sides are parallel. And we know that it's a rectangle because there's a right angle. There's really two right angles here, which means there have to be four right angles. So if it's a rectangle, so opposite sides have to be equal, which means this has to be 15. Now, if this has to be 15, does that also tell you what BC and QR are? The answer is yes. They have to be half of whatever's remaining. So 27 minus 15 is 12, which means this side has to be 6, and this side has to be 6. Because AR is equal to BE, because it's an isosceles trapezoid, AR has to be 10. So if AR is 10 and QR is 6, what's AQ? Now you can use the Pythagorean theorem, but yeah, it's 8. What kind of a triangle, by the way? What kind of a special triangle is this? This is actually a 3, 4, 5 triangle. They're all divisible. 6 and 10 are divisible by 3 and 5, multiplied by 2 each, which means the 4 is multiplied by 2 to get the other side as well. If you wanted to use the Pythagorean theorem, you would say, let's say 6 squared plus b squared, a squared would be the 6, equals the c squared, which is 10, and then you could do the Pythagorean theorem. 6 squared is 36, plus b squared equals 100, and subtract 36 from each side gets you 64. Take the square root of each side, and b equals 8. b actually equals plus or minus 8, because the square root of something is actually a plus or minus that number. However, when you're talking about a distance, you can drop the negative number. So when you're talking about a distance, you could just say the answer is 8. Okay, let's take a look at the homework one that I wanted to go over. The one on the homework, which I thought was an interesting one. Okay. All right, find the area of the rhombus shown if WY is 30 centimeters. So we need to figure out the entire area of the whole rhombus. Now, how would you figure that out? Let's figure this out for a second. If WY is 30, that means this is 15 and this is 15. Now, it is true that the area of the rhombus is base times height, but the problem over here is we don't have the base times height. We have the base. I mean, the base is x plus 9. Every side has to be x plus 9, of course. This is x plus 9, and this is x plus 9, and this is x plus 9, because all sides have to be equal when you're talking about a rhombus. This is 15 and this is 15 because diagonals of any parallelogram, including a rhombus, bisect each other. This is also a right angle because it's a rhombus as well. So find the area of the rhombus. Okay. Now, one possibility is to find the height. I don't know here how easy it would be to find the height. Although if you Well, there are a few different ways I could think of. I mean, for example, you could take the W, you could take an altitude and put it down here, and if you took an altitude and put it down there, this would be an isosceles triangle. So you could do it that way. But there's another. I think that there's a simpler way to do it, and that is the Pythagorean theorem. Each of these four triangles are right triangles, right? So, for example, if we took, let's say, this right triangle here, we could use the Pythagorean theorem. A squared plus b squared equals c squared. Now, a squared, let's say, is 15, plus b squared, which is x plus 6 squared, equals the hypotenuse squared, which is x plus 9 squared. And this is going to get a little complex. This is obviously a quadratic equation, so we're going to have to solve this a little bit. But if you remember this from algebra, great. If not, I'll go over it quickly. 15 squared is 225. Now, x plus 6 squared means x plus. Oh, there's a simple form. Okay, fine. So there might be a simpler formula. I may be over analyzing this, but it's okay. You can do it algebraically too. X plus 6 squared really means x plus 6 times x plus 6. Which is x squared plus 6x plus 6x, which is 12x, plus 6 times 6, which is 36. And then you could do the same thing to the other side. The other side you could do, this is also x plus 9 times x plus 9. And this becomes x squared plus 18x, because it's x plus 9x plus 9x is 18x plus 81. And the way to solve a quadratic equation like this, well, actually, one second, you can't solve. Yeah, in order to solve this, you would have to. Yeah, you'd wipe out the x squared term. Well, okay. Well, I mean, this is actually a very easy problem to solve, because by subtracting the you can cancel the x squared term, and once you cancel the x squared term, you don't even have a quadratic equation anymore. You know, to get rid of it, you can subtract the x squared from this side and subtract the x squared from this side, and that wipes them out of both sides. So now all you have left is 12x plus 225 plus 36 is 261 equals 18x plus 81. And then you can, let's say, subtract 81 from this side, subtract 81 from that side. So you got 12x plus 180 equals 18x. And then you can subtract 12x from this side and subtract 12x from that side. Again, a little algebraic manipulation. And you've got 180 equals 6x. And then divide each side by 6, and you have x equals 30. Once you have the x, so now x plus 9 becomes 30. I'm sorry, not 39, sorry. And x plus 6, of course, becomes 36, once you know what x is. Notice what type of triangle? This triangle is actually an 8, 12, 13 type triangle, because that's one of the three types. Remember, there was a 3, 4, 5, which we saw last problem. There's a 5, 12, 13. I'm sorry, not 8, 12, 13. There's an 8, 15, 17. But this is actually a 5, 12, 13 triangle. It's just a multiple of 3. So now that we have this, well, now we can. Now we still have to get the. We actually still have to get the altitude. Let's see. We've got. Let's see. Well, yeah. Well, you can just get the area of each triangle and just multiply by 4. So the area of each triangle. Now, of course, the x plus 9 is 39. This x plus 9 is 39. This x plus 9 is 39. This is 36. Once we do that, we can take the area of any triangle. Now, the area of any triangle is the base times the height divided by 2. Now, for any of these 4 triangles, it's 36 times 15. So 36 times 15 divided by 2. Now 36 times 15 is going to get you 540 divided by 2, so the area is 270. So the area of each of these four is 270. Add them up, and you have the entire area of the rhombus as 1080. Okay, so there's another formula that would make it this a little simpler. So we did it the complicated way. All right, listen, as long as I get the right answer, and there are other ways you could do it also. You know, you could actually draw an altitude and figure that out as well. So there, there are other possibilities as well, but this was one way of doing it. All right, let's see what other. You know, honestly, a lot of these things. What's going on here? All right, a lot of these things are are really things that I would just cover that we already did. So I think I know it's a little early, but I think we can stop here for today. And I want to wish everybody a very happy Thanksgiving. Next week we're going to start with some new material for the first time in a little while. And thank you very much for coming. And I'll see you. Have a wonderful holiday, and I'll see you next Monday.